This video looks at section E of the annuities module. In this video we're looking at future value of an ordinary annuity. Now in the previous video we looked at present value, which was what amount do we need to put in or invest now to get payments later, or if I want money now, how much do I need to repay later to have that. Now future value of an annuity is regular payments are made with a lump sum at the end. So you can think about a superannuation here. How much money do I need to put in along the way in order to get so much at the end? Or some kind of investment fund. So our examples are savings schemes where regular payments are made to build to a lump sum at the end of a period. These are also called sinking funds in business. They're used to save for the replacement of major capital items. So you start putting money in. A lot of governments do it as well. So you can see from this timeline that in this one we just got a 5-year timeline. So this is where I want the money at this 5-year period, and we want to know, well, how much do I need to keep putting in order to have that money at the end? And these are all the payments with their interest. So the future value of an annuity is the value of all the payments at the end of the term, and it's given by the equation here. Now note this equation could also be written as R1 plus I to the n minus 1 with a bracket around that, all over I. So we can put that R with the bracket if we want to. Either way, it's exactly the same. Don't get stressed. So S is the future value of the ordinary annuity, R is a periodic payment, I is the interest rate per period, and N is the number of payments. So let's look at an example. George deposits $150 into a bank account at the end of the month for 5 years at the rate of 7% compounded monthly. So we've got $150 is our payments, we've got 5 years, 7% per annum, but it's compounded monthly. What lump sum will we have at the end of the 5 years? So we can see my timeline here. Now the reason I have 60 here is we're looking at N as 5 years, but we're timesing that by 12 because it's per month. You know, that's when he wants to make those payments every month. So it's going to be 5 times 12, which is 60 months. Our interest rate, which is 7%, that would be per annum. So if I want it to be per month, I need to divide by 12. Now 7% as a decimal is 0.07, so it's 0.07 over 12. And if I plug that into my calculator, I get a recurring decimal. It's 0.0058 and then the 3 repeats. So I'm going to leave it as that fraction, so I'm not approximating twice. In the textbook it has an approximate for that decimal. I'm going to leave it as a fraction though. We also have that our repayment is going to be $150. So we write out our formula, which is S equals R1 plus I to the power of n minus 1 all over I. Plug in what we have, 150, 1 plus 0.07 over 12, all to the power of n, which was 60, minus 1, all over 0.07 over 12. Again, when you're plugging this into your calculator, you can just go straight from this to the answer. Just remember to use brackets. So if you're going to put in the 150 first, put in 150 times and then use a bracket. Okay, so what you've got is 150 times bracket. Now I've got another bracket. 1 plus 0.07 divided by 12. Put in a bracket. Now I put to the power of 60. Now I can subtract 1 and I need to close my bracket because we want all of this to be divided by what's on the bottom. So then we go divided by. Now I would put a bracket around here. It's not essential because of order of operations, but you know that you're dividing by all that, so sometimes it's good just to clarify in your mind. So divide by that and then you will get your answer. So a lot of students have troubles here because of putting into the calculator and getting those brackets in the right spot. So remember you need to do that because of order of precedence or order of operations. So you get a $10,738.94. I can't fit a therefore statement. I've run out of room. because I've shown a lot of steps, but your therefore statement would be the future value of the annuity is $10,738.94 rounded to the nearest cent. So what's happening here is he's going to end up with that amount of money if he puts in $150 per month for that 5 years. So let's look at another example. Wally is planning for his retirement in 20 years. When he retires, he wants to have a lump sum of $300,000. Don't know about you, I'd like a lot more than that, but anyway. His financial advisor has suggested a 5% per annum was suitable interest rate to consider. How much will he have to pay per month into his retirement fund? And we're going to assume it's an ordinary annuity. So if we look at our timeline here, it's 20 years and it's per month. So N is 20 years, which is 20 times 12, which gives me 240 months. Our interest rate is 5% per annum, so we need to divide that by 12. So that's 0.05 over 12. If you plug that on your calculator, again you get a really long decimal, so I'm going to leave it as that fraction. We want to end up with an amount of 300,000. So we need to rearrange our formula. So our formula was S equals R, 1 plus I to the N minus 1 all over I. I want that R on its own, so I need to divide by all of this. Now if I put all of this underneath here, I can just take that I straight up. So what I end up with is R equals SI all over 1 plus I to the N minus 1. Okay, now in an end of course test you are expected to be able to transpose the formula. You will be given the formula with the S out the front. Okay, so from here let's plug in everything I've got. I've got 300,000 times by my I all over 1 plus 0.05 all over 12. That's to the power of 240, and then I take 1 away. Again, when you plug it into your calculator, remember you need a bracket around all of this because you want to divide all of the top by what's on the bottom. Again, you might want to put a bracket around the top, so instead of putting enter at the end. When you plug it in your calculator, you get approximately $729.53. So finish with a therefore statement. So I've just got therefore Wally will have to pay approximately $729.53 per month, and it should be for 20 years. Okay. So what now? Practice Annuities E1, the textbook.